Statistics for Management. This is for the MBA first semester syllabus of Anna University. It contains 5 units. In the first unit is titled as Introduction. The content in the first unit are basic definitions and rules for probability, conditional probability, independence of events, Bayes theorem, and random variables. Then probability distribution, that is binomial, Poisson, uniform, and normal distributions. Hence, it would be presented in 2 videos. First unit. In this video contains probability, and the remaining unity following will follow. Then, so I am Dr.M.Wilson, formerly Vice Principal and HOD of Commerce, Scottish College, Nagercoil. Facebook is M.Wilson, MW, UTV is MWN.com. Thank you. To MWN Publications. I am much happy to explain about the concepts related to the syllabus of Statistics for Management of Anna University, meant for first semester MBA. And in the first unit, that topic is probability. I wish to start from the first unit, the probability, then theoretical distribution. And I hope that you will be enjoying and studying. And another thing is, you are going to study without any expense. This may be available after a few days in Amazon ebook, and also I am trying to give it in hard copy also. Thank you very much. Probability. The probability theory was developed due to the gambling. The people's mind are with the gambling, and in olden days the kings are very much particular and involved in some games that is connected with the probability, whether they will be winning the game or not, that will be there. And they encouraged the mathematicians during their period to develop theories to win the games. And in this respect, first one is Pascal, who tried to answer the question raised by one king. And gradually, it was the theory got momentum, and in 18th century, and more contributors are there. The important contributors for the development of probability theories: D. Murray, that is in 1718, James Berrowley in 1713, and Bayes in 1768. The theory was further developed by mathematicians like Fisher and Pearson. Then about the probability, meaning of the probability, and we just want to know about the meaning. It is, as I told, the game of chance, like tossing of coin, throwing of die, playing cards, first developed in this area only. Then it was applied to the managerial aspects to solve managerial problems for better decision making. Probability is concerned with predicting the occurrence or non-occurrence of an event in future in our day-to-day life. That the chances of happening an event in future may be 100% or 20% or 30%. That kind of calculations to be done based on the past events. Now let us study about the approaches to probability. There are 4 approaches to probability. They are: one, classical or priori approach; second one, relative frequency or empirical approach; third one, axiomatic approach; fourth one, subjective approach. Then first one is classical approach to probability. It is the oldest method of knowing the probability. This method is based on the origin of gambling. In classical approach, the probability of an event is the ratio of number of favorable outcome of an event to the number of possible outcome. Total possible outcome should be known, and the expected event, that outcome, how much is there, that would be known. So thereby, probability of occurrence of A means small a by A plus B. A is number of occurrences favorable to the occurrence of A. Number of outcomes favorable to occurrence of A. A plus B is total number of possible outcomes. The probability of non-occurrence means it may be mentioned as Q, that is QA, that is equal to B by A plus B. Let us take an example. In the throw of a die, probability of outcome is 5. Total number of outcome is 6 in a die. Contains 6 sides. And probability of getting any one number means 1 by 6. That is the expected events outcome will be 1 and total outcome is 6. Thereby 1 by 6 1. Then relative frequency approach to probability. This approach is developed by British statisticians during 1800. This approach is useful for solving the problems which could not be solved through classical approach, that is the oldest approach. This approach stated that the valid procedure for determining the probabilities through repetitive experiments. For example, if a coin is tossed once, then the probability of getting head is 1 by 2, that is 0.5. If the coin is tossed repeatedly, say for 10 times, one coin can get 3 heads and 7 tails. There may be possibility. Hence, the probability of getting head is 3 by 10, that is 0.3. When the number of repetition is increased to 100 times, one may get the head for 42 times. Now the probability of getting head is 42 by 100, that is 0.42. So the repetition will give more standard. When we are repeating many times, then we are going to reach the standard. Here the standard is 0.5. So if they increase to 200, 300, like that in our study also we are repetitively studying, we will be master in that particular area. Then the third approach is axiomatic approach to probability. This is developed by Kolmogorov, a Russian mathematician. According to this approach, the probability of occurrence of either of two events, there would be two events, is the total of the probability of occurrence of each event individually. This approach is applied when the events are mutually exclusive, that is disjoint, that means independent. For example, if X and Y are two mutually exclusive events, then the probability of occurrence of either X or Y is Px union Y equal to Px plus Py. Then subjective approach to probability. Fourth one is subjective approach. This approach is developed during 1922 by Frank Ramsey. This approach is otherwise called as personalistic approach. According to this approach, probability may be defined on the basis of the personal judgment of an individual. The personal judgment of an individual depends on evidence and experience of the individual. For example, an individual may judge the probability of arrival of a train at 9:30 a.m. as 0.7 on the basis of punctuality in the arrival of the train at 8:30 a.m. in previous days. Second one, an individual may judge the probability of his getting above 70 marks in an examination is as 90%, that is 0.9, on the basis of his hard work and the nature of the question papers. Hence, an individual assigns probability of occurrence of an event from 0 to 1. If one is very sure that an event will occur, then he may determine the probability as very close to 1. The main limitation of this approach is that the value of probability differs from one individual to another. Now let us study about the fundamental concepts of probability. There are 9 concepts. They are random experiment, sample space, event, equally likely events, mutually exclusive events, exhaustive events, independent events, dependent events, and complementary events. Let us study these one by one. First one is random experiment. Random experiment is an experiment and the result of it depends on chance. So for example, The tossing of coin, the result may be head or tail. Here in the random experiment, the outcome we may know either it would be head or tail. The experiment conducted to obtain an outcome is called random experiment. In the tossing of coin, the head and tail may appear. In throwing of die, outcome are 1, 2, 3, 4, 5, 6. In a random experiment, any one of these outcome may occur. Sample space. Sample space means a collection of all possible outcomes. It may also be termed a set of all possible outcomes. The sample space for tossing a coin are head and tail, The sample spaces for throwing a die are also known, that is 1, 2, 3, 4, 5, and 6. Each possible outcome in the sample space is called sample point or element. Then third one is element. An element of the sample space is called event. Here we are studying event. An element of the sample space is called event. It is also called as a sample point. Event may be simple event and complex event. If the event contains one element, it is called a simple event. If the event is defined by more than one sample point, that is element, it is called compound or complex event. Fourth one is equally likely events. If all the events of the sample space got equal chance of the occurrence or being selected, it is called equally likely events. In the tossing of a coin, the head and tail are equally likely events. In the throwing of a die, either of 1, 2, 3, 4, 5, 6 are equally likely events. Fifth one is mutually exclusive events. Mutually exclusive events mean those events or events, the occurrence of which prevents the possibility of the occurrence of other. It means if one event occurs, the other event will not occur. When a coin is tossed, either head or tail may occur. Hence, head and tail are mutually exclusive events. Sixth one, exhaustive events. Exhaustive events mean that at least one of the events should necessarily occur. In the throw of a die, there exist 6 exhaustive events. Seventh one, independent events. Independent events are those events, the occurrence of which does not affect the occurrence of other events. Independent events have no influence over the occurrence of other events. The occurrence of head in a toss of coin won't affect the occurrence of head in the second and subsequent tosses. Then eighth one, dependent events. Dependent events are those events, the occurrence of which affects the occurrence of other events. For example, the probability of drawing a cue from a pack of 52 cards is 4 by 52. Yes, cues are 4. That is 1 by 30. In the first draw, if the incident happened and the card is not replaced, the probability of getting another queen card is 3 by 51. If the queen card is not replaced and then the probability of getting a king card is 4 by 51. Then complementary events. The non-occurrence events are called complementary events. The throw of a die, if we expect number 5 should occur, then the other events, that is numbers 1, 2, 3, 4 and 6 are complementary events. Now let us study about the set theory. Set theory is applied in the modern approach to the probability theory. The important concepts of set theory applied in the probability theory are stated as follows. First one is set. Set means a collection of well-defined and specified elements of objects. Well-defined one. The books in a library, the students in a class, the employees in a company are the example. Then universal set. The set consisting of all the elements under the consideration is called universal set. For example, if A is a set and U is a universal set, then every element in A must be in U. Null set. The null set or empty set is a set having no element. Subset. When every element of a set is also elements of another set. The first set is called the subset of the second set. For example, set A 1, 3, 9 and set B 1, 3, 1, 2, 3, 4, 5, 6, 7, 6, 9, 10, 20 are the two sets. Here A is called the subset of B, since every element of A is also elements of B. It can be denoted by A is an element of B. Then equal sets. Two sets are okay. Two sets are called equal sets when the elements of both the sets are the same. For example, A and B are equal sets when A equal to 3, 5, 7, 9 and B equal to 3, 5, 7, 9. It can be represented by A, is element of B and B element of A. Now let us study about the important functions of set. First one is intersection of set. When two sets are having few common elements, then it is called intersection of sets. If set A 4, 6, 8, 10, B 1, 2, 5, 6, 10, the elements of 6 and 10 are common, which are called intersection of sets A and B. Then intersectional set can be diagrammatically represented as follows. Then disjoint sets. When two sets are not having common elements, then the two sets are called disjoint sets. For example, A 1, 5, 7, 9 and B 2, 3, 6, 10 are two sets. These sets do not have common elements. Hence A and B are called disjoint sets. They will be diagrammatically represented here. Third one is union of sets. The set of elements belonging to two sets is called union of sets. For example, A 1, 2, 3, 4, 5, B 2, 4, 6, 8, 10. The elements belonging to A and B are 1, 2, 3, 4, 5, 6 and 10. They are called union of sets. It can be written as 11, 2, 3, 4, 5, 6, 8, 10. Then fourth one is complement of a set. A set of all elements to the universe except the elements of a particular set is called complement of a set. If U equal to 1, 2, 3, 4, 5, 6, 7, 8 and A 2, 3, 5, then the set of elements 1, 4, 6, 7, 8 is called the complement set. That is represented in a diagram as follows. Then fifth one is difference of two sets. The set of element of a set except the intersection elements of the set is called the difference between one set with another set. If A is 3, 4, 5, 6, 8, B 4, 5, 6, A is that difference to B is 3, 8. It can be represented in the following diagram. Then third concept is permutations and combinations. Permutation and combination are the important techniques for calculating probability of an event. Permutation means the arrangement of number of objects in a definite order. The number of permutation depends upon the total number of objects and the number of objects taken at a time for arrangement. The formula is given below. Then illustration 1. Find out the number of ways 5 books in a library can be arranged by taking all the books at a time. Then solution for illustration 1, that is NPN equal to n factorial. Here 5 is a n, that is a 5 factorial. Factorial means 1 into 2 into 3 into 4 into 5. 6 factorial means 1 into 2 into 3 into 4 into 5 into 6. Here the total is 120. Hence 120 times the 5 books can be arranged by taking each book at a time. Then second one, a company received 10 applications for 4 posts. Find out in how many ways 4 people can be selected for the 9 applications. The number of ways 4 people can be selected from the 9 applications is calculated as NP or equal to n factorial divided by n minus r factorial. That is np4. That is n is 10, p4. 10 factorial divided by 10 minus 4 factorial. That is 10 factorial by 6 factorial. It is very easy here. 10p4 thereby 10 minus 4. Suppose 10p5 means 10 minus 5. 10p2 means 10 minus 2 factorial. That is equal to 1 into 2 into 3 into up to 10 divided by 1 into 2 into 3 into 4 into 5 into 6. That value gives 5040. The next concept is combination. Then combination is a technique for selection of objects without considering their order. The formula for calculating combination is NCR. That is n factorial divided by n minus r factorial into r factorial. NCn equal to 1. NC1 equal to n. N equal to number of objects, r equal to number of objects taken at a time. The symbol is factorial. Here in illustration 3 is given. A basket contains 10 oranges. In how many ways? 3 oranges can be selected from the basket. For the illustration 3, the solution is 10 factorial divided by 10 minus 3 factorial into 3 factorial. Normally, you have to say that r there is 3, then 10 minus 3, 7. That is 7, 3 factorial. Otherwise, if it is 6 means 6 factorial and 4 factorial. 4 means 10 minus 6, 4. Yes, like that you have to do. Here, that is 120 base. The answer is 120 base. Then illustration 4. A coin is tossed 5 times. Find out the probability of obtaining 4 heads, 5 heads and 3 or more heads. Interesting problem. Getting a head means P 1 by 2. Probability of getting a tail, that means Q equal to 1 minus 1 by 2 or 1 by 2. Probability of getting 4 heads means P4 equal to 5C4 into P4Q1. You please note that here P is 4. Expected 4 heads is 4. Then Q will be 1. That means 4 plus 1 should be 5. Here 5, see, that is 5 is taken for this. 5 factorial divided by 5 minus 4 factorial by 4 factorial. That means 1 factorial and 4 factorial. That 1 plus 4, 5. That basis you have to find out. Here 1 by 2 by raised 4 and 1 by 2 raised 1. No problem. That means 1 by 2 raised 5 it can be. The answer is 0.156. Then probability of getting 5 heads is P5. That is P5 Q0. That means 5 minus 0. That is equal to Q0 means 5 minus 5. That is 5 factorial by 0 factorial by 5 factorial. Answer is 0.031. Then probability of getting 3 heads, 3 or more heads means that you have to make P 3 or more heads means probability of 3, P4, P5. That is 5, 3, C3, P3, Q2. You see that the 3 should come first, then Q2. Total should be 3 plus 2, 5. Like that 5, C4, P4 and Q1. There is 4 nearby. That's why the 4 should be taken for P. 5C5. That is P5, Q0. Total should be 5. That's why 0. Then 5 factorial by 2 factorial by 3 factorial. The answer gives you 0.417. Then illustration 5. Find out the probability of getting 3 heads, at least 2 heads, and at least 1 head when 5 coins are tossed at a time. Here you have calculated just for the 3 heads. That already you know how you have to calculate. At least 2 heads and at least 1 head you should know. Then probability of getting 3 heads means P3. That quite natural. 5C3, P raised to 3, Q raised to 2. And your apply means the answer will be 0.313. Then probability of getting at least 2 heads. At least 2 heads means 2 heads plus rest of that. P2 plus P3 plus P4 plus P5. Then the formula is given 5C2, P raised to 2, Q3. 5C3, P P raised to 3, Q 2. Then for here you just see first 5, thereby the total of that would be 3 plus 2. Here 4 plus 1. Next one 5 plus 0. Then the answer is 0.813. Then it may be also calculated in another way, that 1 minus that other rest of the thing you have to take into account. That means probability of getting at least 2 hits means that you have to deduct 0 hits, 1 hits, and 0, 1, and 2 hits. Thereby 1 minus first you are going to take P2. Here it would be you have to take minus 2 component only, because 0 and 1. 1 minus pi c 0, then Q 0, P 5. Then P raised to 0 and Q raised to 5. Then 5C1, Q raised to 1 into P raised to 4. Anyway, that is giving the same value only. It may be taken as P also. P raised to 0 plus P raised to 1. Both are same. The answer is 0.813. Same like the previous answer. Then is C, probability of getting at least 1 hit. Probability of getting at least 1 hit means P that is greater than or equal to 1. That is P1 plus P2 plus P3 plus P4 plus P5. Then you have to calculate accordingly and you get the value of that. Now let us study illustration 6. The average percentage of pass in a test paper is 70. Find out the probability that out of a group, 7 students at least 4 passed in the examination. The percentage of pass in examination is 70%, that is 0.7. Hence Q equal to 1 minus 0.7 equal to 0.3. The probability of passing of 54 or more students, at least 4 students, P is greater than 4 equal to P4. You have to take into account P4 plus P5 plus P6 plus P7. By applying the formula, you are getting 0.852. Then the probability of success in an examination of students in a village is 0.2. When the probability that out of 6 students, none or 1 or 2 and at least 1 will be succeed in the examination. N equal to 6, P equal to 0.2, thereby Q equal to 1 minus 0.2 equal to 0.8. Then NCR equal to 6 CR P raised to R Q raised to N minus R equal to 6 CR 0.2 raised to R, then 0.8 raised to 6 minus R. Then probability of non-success means nobody succeeded, means 6C0, that is 0.2 raised to 0, 0.8 raised to 6. That answer is 0.262. Probability of one success means means 6C1, 0.2 raised to 1, then 0.8 raised to 5. That is one success. That is 6 factorial by 5 factorial by 1 factorial, 0.2, then 0.328. That is for 0.8 raised to 6. The answer is 0.328. Then here the total would be 6, because 6C1, 6 is again in the previous case 5, thereby 3 plus 2 or whatever it may be, it would be 5. Then the answer is 0.396. Then probability of 2 success means exactly that value. 2 means 0.2 raised to 2. Then success expected is 0.2, then 2 raised to 2. Then 0.8 raised to 4, because 2 plus 4 equal to 6. Then the answer is 0.24. Then probability at least one success One success at least means 1 minus probability of no success. Very easy. That you should not go for one success means you should not go for P1 plus P2 plus P, like that you need not do. Like instead of that you can take 1 minus that probability of no success, that is 0.262, 0.738. You have to note into account that at least one success means then the probability chance is greater quite naturally. Okay, if one success means that is happen to be low, at least one means probability means 0.738, one may pass, two may pass, like that. Then let us see the illustration 8. 12 coins are tossed at a time. Find out the probability in a single tossing for the following outcome. Less than 4 hits. Then 9 or more hits, like that. 5 questions have been asked. Now let us see the solution for the illustration. That is probability of getting a head P equal to 0.5. Probability of getting tail is Q equal to 0.5. That is 1 minus 0.5. Probability of getting at least less than 4 heads means less than 4 heads means P0 plus P1 plus P3 plus P2 plus P3. That calculation you know already. Thereby you are calculating and getting 0.073. Then probability of getting by multiplying 100 it will be in percentage, that means 7.3%. Probability of getting 9 or more hits. 9 or more hits, 9 should be there. P9 plus P10 plus P11 plus P12, and thereby you are calculating, and the value answer is 0.073. The second one is probability of getting at least 7 hits. At least 7 hits, quite naturally, you know, already also we are doing. The maximum is 9, thereby P7 plus P8 plus P greater than 9. Okay, greater than or equal to 9 means already you have calculated. That's why you can go for that. Applying that, say, 12 head 12, instead of calculating P9 plus P10 plus P11 plus 12, already you have calculated P greater than 9. So you are adding P7 and P8. The answer is 0.382. Then probability of getting no heads means 12 heads, 12 coins means 0, 0.5 raised to 12. Thereby answer is 0.00024. Getting no heads at a time for 12 coins tossed continuously, tossed at a time, it's less probability only. Then probability of getting at least 100. At least 100 means 1 minus P0. Okay. Otherwise, you have to get P1 plus P2 plus P3 plus P4 plus P5 plus P6 plus 7 is 8 plus P9 plus P10 plus P12. Instead of that, in easy manner, you are calculating. That is 0.998. There is more chances. Then ninth illustration. A basket contains 300 apples. Out of the total apples, 120 are defective. When 7 apples are selected at random, determine the probability that some 6 questions are asked. Then you have to calculate accordingly. Probability of defective equal to 120 by 300. Yes, the 120 are defective out of the 300. Thereby 0.4. Probability of getting good equal to 1 minus 0.4, that is 0.6. Then probability at least one defective is, that is P1 to up to P7 you have to calculate. Instead of that, you can calculate 1 minus Q0 equal to 1 minus 7 C0, 0.6 raised to 0, 0.4 raised to 7. The answer is 0.998. More chances. Okay. Then probability of at least at the most 5 defective. At the most 5 defective means less than or equal to 5. You have to take into account how the utmost is calculated. That is P0 plus P1 plus P2 plus P3 plus P4 plus P5. Or it may be taken as 1 minus P6 plus P7. What are all not available, you have to calculate. Then easy manner is 1 minus P6 plus P7. That answer is 0.982. Then probability of all 7 defective is P7. All these are 7. Exactly 7. That here there is more than or less than or at most is not there. Thereby exact number is to be taken. That is 7C7, 0.4 raised to 7 and 0.6 raised to 0. Answer is 0.002. Then probability of getting R7 goods is, then R7 is that P7 R7 P0 okay equal to 7C0, that is 0.4 raised to 0, 0.6 raised to 7. That is answer is 0.028. Then probability of 4 defective is P4 equal to exactly that number you can put and calculate. 7C4, 0.4 raised to 4, 0.6 raised to 3. The answer is 0.19. Then next one is theorems of probability. The theorems of probability are otherwise called as rules of probability or laws of probability. There are two important theorems of probability. They are addition theorem and multiplication theorem. Addition theorem of probability contains two theorems, namely theorem of total probability and generalized theorem on total probability. First one, theorem of total probability. Now we have to calculate, we have to know when events are mutually exclusive, this theorem should be applied. If two events A and B are mutually exclusive, then the probability occurrence of either of the events A and B, A or B is equal to the sum of the probabilities of A and B. That is P, A or B equal to P, A plus B. Either one event to be occurred means you have to add P, A plus P, B. If A1, A2, A3, A4 like that up to AN are mutually exclusive events, then the probability occurrence of either of the events is the sum of the probabilities of A1, A2, A3 up to AN. That is denoted here. Then example, from the example you can follow that. An urn contains 5 white, 3 red and 4 black balls. Find out the probability of getting a white or black ball in a single draw, either one white ball or black ball when they draw. Then probability of getting white ball is equal to 5 by 12. Probability of getting a red ball is equal to 3 by 12 as per the illustration. Total balls are 12. Probability of getting either of red or ball means 5 by 12 plus 3 by 12 equal to 8 by 12 equal to 2 by 3. Then generalized theorem of total probability. This theorem should be applied when the events are not mutually exclusive. If A and B are two events which are not mutually exclusive, then the probability of occurrence of either A or B should be calculated. This is addition theorem. That's why we are making like that. P A or B equal to P A plus P B minus P A and P B. And if A and B and C are three events which are not mutually exclusive, then we have to calculate accordingly. Then illustration 11 has been asked. A card is drawn from a well-shoveled pack of 52 cards. What is the probability of a card being either red or a jack? Then solution we are going to. Here the total outcome is 52. That is called sample points. Since there are 52 cards. Let A be the event that the card is red. Then A consists of 23 as sample points because 26 red cards are there. Since there are 26 red cards, B denotes the event that the card is jack. B consists of 4 sample points since the number of jack cards is 4. Hence, the value should be calculated accordingly. 26 by 52 plus 4 by 52 minus 2 by 52 because there are two events, that by 2 by 52. The answer is 7 by 13. Then illustration 12, that is a box contains 15 balls numbering from 1 to 15. Find out the probability that a ball selected at random is a ball with a number that is multiple of 3 or 5. Understand? Multiple of 3 or 5. Total sample points 15. That is 15 balls. Let A be the event that the ball with the number that is a multiple of 3. So A has 5 sample points. That is multiples of 3 means 3, 6, 9, 12, 15. There are 5 sample points. By multiplying 15, dividing 15 by 3 also you can derive. Let be the event that the ball is numbered in the multiple of 5. So B has 3. That is 15 by 5. That is 3. That point, sample points are 5, 10 and 15. Since A and B are yes, that 15 as common sample point, we have to calculate accordingly. The answer would be 5 by 15 plus 3 by 15 minus 1 by 15. That one ball is selected, that is 1 by 15. 2 balls to be selected means 2 by 15. Then illustration 30. The probability that a contractor will get a contract is 1 by 5. The probability of not getting a contract is 2 by 3. The probability of getting at least 1, at least means plus, okay, keep in mind, at least 1 is 1 by 4. Find out the probability that he will get either of the 2 contracts. Simply we can say that 1 by 5 plus 2 by 3, then minus 1 by 4. So like that would be. The answer is 37 by 60. Then second one is multiplication theorem. Then multiplication theorem probability is applied in 2 situations. They are multiplication theorem of a probability when events are independent and multiplication theorem of probability when events are dependent. So it is good to keep in mind, easy to keep in mind independent and dependent. Here one multiplication theorem of probability when events are independent. If 2 events A and B are independent, then the probability that both will occur, both means only multiplication. Either or means addition will be equal to the either equal to the product of the probability of these 2 events. That is the PA into PB. Right. Then illustration 14. 2 students A and B are independently solving a problem. Probability of A solving the problem is 1 by 5 and the probability of B solving it is 2 by 3. What is the probability of both of them will solve the problem? That means you have to multiply. Both means you have to multiply. 1 by 5 into 2 by 3. That is 2 by 50. Then illustration 15. A box contains 5 red, 4 black and 3 white balls. What is the probability of getting a white, a black and a red ball? Then all multiplication only. The outcome is 12. Thereby getting 3 means that will 3 by 12, then 4 by 12 and 5 by 12. Multiply 3 by 12 into 4 by 12 into 5 by 12. That is 5 by 54. Then multiplication theorem probability when events are dependent. It is otherwise called as conditional probability. 2 events are denoted as dependent events when occurrence of events are denoted as dependent events. When the occurrence or non-occurrence of one event in any trial affects the probability of other event in the other trial. Probability of the other trials, okay. Probability occurrence of both the events when events are dependent is stated below. Illustration, it will be clear for everyone. Illustration 16 explains a bag contains 6 white balls and 4 red balls. The balls are drawn simultaneously, okay, without a replacement of the first ball. When what is the probability that both balls are of white color? The sample points is 6 plus 4 equal to 10. Probability of getting a first white ball PA is 6 by 10. Since there is no replacement of the first draw, the probability of getting the second white ball is 5 by 9. Then hence the probability of getting 2 white balls in the 2 draws without replacement is 6 by 10 into 5 by 9 equal to 1 by 3. Very easy one. Then illustration 17. From a well shuffled pack of 52 cards, 2 cards are drawn. at random. What is the probability that both of them are Qn cards? Assume that there is no replacement. Understand? No replacement means then one card is reduced. Then outcome is 52. Total Qn cards 4. Probability of getting a Qn card in the first try is 4 by 52. Since there is no replacement of the card, the probability of getting the Qn card in the second try is 3 by 51. Therefore, the probability of getting 2 Qn cards means you have to, add that. So you have to multiply it. 4 by 52 into 3 by 51. Both means multiplication. 3 by 663. Next, we have to study the Bayes theorem, a rule for the inverse probability. The calculation of unknown or old probabilities named priori probabilities from the new probabilities is called posterior probabilities or inverse probability. Inverse probability can be calculated through additional information available in the past records. It is one of the important application of the conditional probability. Since conditional probability states that the occurrence of one event is due to the occurrence of a particular event or reason. Inverse probability is derived by a British mathematician named Thomas Bayes in the year 1763. The rules of the theorem are stated below. Let B be an arbitrary event which can only be occur in the conjunction with one of the n mutually exclusive and exhaustive events A1, A2, A3 up to An. Then accordingly it has been shown how it is calculated. Then after looking into the illustration, we can easily understand the points. Illustration 8 is stating that two persons are competing for a management post in a company. The probability is that the first and second will win are 0.7 and 0.3 respectively. The first person wins. The probability of opening a new branch is 0.8 and the corresponding probability is 0.4 if the second person wins. What is the probability that the new branch is opened? The solution is that the 0.7 into 0.8, that first probability of getting for him is 0.7 and this was 0.8, then plus 0.3 plus 0.4 equal to 0.56 plus 0.12 equal to 0.8. This can be known that probability of the first person win is 0.7, probability of the second person win is 0.3. Then for the first person we are applying 0.7 into 0.8, opening the new shop is 0.7. And second one is 0.3, the probability of winning in the chance is 0.3, and when we win, the chances of opening is 0.4. Thereby we are multiplying both of them and adding, you will be getting 0.68. The 19th illustration. A company manufactures a product, namely X, in the two of its factories. The factory 1 manufactures 70% of the product. Factory 2 manufactures 25% of the product. It is found that factory 1 manufactures 70% standard products of X out of 100 products of X, and factory 2 manufactures 60 standard products out of 100 products of X. What is the probability that a product X selected at random from factory 1 is of standard quality? Also calculate the revised probability. The solution is very clear that when compared to the previous problem illustration, it would be 0.75 into 0.7 plus 0.25 into 0.6. That answer is 0.675. The all explanations are given above. Then second one is probability of getting a standard product of X from factory 1 is 0.75 into 0.7. That is quite nice. One particular event they are asking. Then calculation of posterior or revised probability, that is somewhat different. That is value of 0.25 for B. For A 1 by for B means 0.525 you have to take into account, and other thing is same 0.52 by 5 plus 0.15. 15 equal to 0.52 by 0.675. Like that for the B also the same. That might mean the denominator that would be 0.15. by 0.675. When you are studying the nature of that value, you can easily keep in mind. Then that would be either or means scale. Old one means either or means it would be, I mean, not sorry, both of them. Sorry. Either or you have to plus, that is you are adding the 0.52 by 0.675 plus 0.15 by 0.675, that would be one value. Total would be one. Okay. Now let us see the illustration. There are three persons named K, L, and M for a sales manager post in a limited company. Their chance of being selected for the post is in the ratio 6:4:3. If K is selected, the probability that he will introduce a new product is 0.5. See, and one more probability is given, additional one, that you have to apply. How you are going to apply is very well when you are looking into the illustration, a solution of that illustration. That is corresponding probability of the introduction of a product or new product is 0.7, and for the M means it would be the corresponding I will introduce a product or M for L is 0.7 and M is 0.4. The chance of introduction of the product when these persons are selected. What is the probability that new product is introduced? Then let the probability of the new product be introduced is PB. PA1 equal to 6/3. PA2 equal to 4/12. 4/13. Okay, first proportion we are calculating. Then PA3 is 3/13. PBA1 equal to 0.5, that is PB by A2, that is just given 0.5 equal to PBA2 is 0.7, PBA3 is 0.4. It is given in the illustration. Then you are applying 6/13 into 0.5. First, okay, very easy one. 4/13 into 0.7. Then 3/13 into 0.4 respectively in the second line and third line of the illustration you are applying. The value is 7/13. Then computation of the expected values. The expected values to be calculated through probability theories or otherwise called as the calculation of mathematical expectation of the random variable. It can be calculated through the following method. Then the properties of the expected value of the random variable. There, the expected value of a constant is the constant itself. EA is EA. EA plus BX equal to A plus BEX, where A and B are constants. When X and Y are random variable, then EX plus or minus Y equal to EX plus or minus EY separate. When X and Y are two independent random variables, then EXY equal to EX into EY. Variance of a random variable. The variance of a random variable can be calculated as follows. Let X be the random variable with mean EX. Then the variance X is stated below. And when we are looking into an illustration, it will be clear for us. Then standard deviation of a random variable. Standard deviation of a random variable is the square root of the variance of the random variable. It can be derived through the same formula used for deriving variance of a random. That is standard deviation equal to square root of sigma x square minus x square, where x equal to EX. Illustration 21 will make clear of that concept. Find out the expected value of the random variable, standard deviation, and its variance when a die is thrown. The random variables have a throw of a die is 1, 2, 3, 4, 5, 6. Hence the probability of occurrence of each value is 1/6. Hence EX equal to 1 into 1/6 plus 2 into 1/6 plus 3 into 1/6, like that. 4 into 1/6, 5 into 1/6 plus 6 into 1/6 equal to 7/2. Then Ex, that is x bar, equal to 7 by 2. Then Ex square equal to 1 by 6 into 1 square plus 2 square. In the previous case, you have taken into account of 1 plus 2 plus here, squaring it. 1 square plus 2 square plus 3 square plus 4 square plus 5 square plus 6 square. That value is 9 by 6. And variance is equal to, based on that, 91 by 6 minus 7 by 2 square. Okay. Variance is the square of the standard deviation. So if it is standard deviation, you have to take into account of the square. Then 2.917. Then standard deviation is, we are taking the square root of it, it means 1.708. Then illustration 20. It has been asked to calculate the standard deviation and variance for the probability distribution. Here, it's 0 means 1 by 16. Then 1 means 4 by 16. 2 means 6 by 16. 3 means 4 by 16. 4 means 1 by 16. Here there are 5 numbers. Thereby central is 2. Thereby 6 by 1. Others are same. See, 4 by 16 for 1 and also 3. And 1 by 6 for 0 and also for 4. Then by applying the same value, 0 into 1 by 16 plus 1 into 1 by 16 plus 2 into 1 by 16 plus 3 into 1 by 16 plus 4 into 4 by 16 plus 4 into 1 by 6. That value is equal to 2. Then square of that, then that square, squaring that means same without square. 0 into 1 by 16 plus 1 square plus 4 by 16, 2 square plus 6 by 16, 3 square by 4 by 16 plus 4 square by 1 by 16. Then the value seems to be 5. Then variance is equal to the formula we are applying, Ex square minus x square, that is 5 minus 2. X is, first one is 2, thereby 2 square. That is equal to 5 minus 4 equal to 1. Then square root of that 1 is 1. So variance and standard deviation are same because the value seems to be 1. Then illustration 23. Find out the expected random variable of getting head when a coin is tossed 3 times. Probability getting 0 head equal to N60 by 1 by Q equal to 36C0 by 1 by 8. Probability getting 1 head as that NC1 by 1 by 1 by P by into 1 by Q raised to 2. That value is 3 by 2. Here 1 by P raised to 2 and 1 by Q raised to 1. The next one 1 by P raised to 3 and 1 by Q raised to 0. 3 means the total would be, index value would be 3 only. That answer is 1 by 8. This kind of calculation, okay, calculation we already calculated. Then we are going to calculate the variance. That's why Ex equal to 1 by 8 plus 3 by 8 plus 3 by 8 plus 1 by 8 equal to 1. Then illustration 24. Game is played by a man with the understanding that he will get 160 for 1 head, 240 for 2 heads and 320 for 3 heads. When 3 coins are tossed at a time, he will not get anything for no head. If the entrance fee for the game is 200, find out whether he can play the game. The man will play the game if he will get more than the entrance fee of 300. Probability getting 0 head means 1 by 8. Probability getting 1 head is 3 by 8. Probability getting 2 heads is 3 by 8. Probability getting 3 heads 1 by 8. The probability of the prize money is x0 equal to 0. x1 equal to 160. Then x2 equal to rupees 240 into 240. x3 equal to 320 according to the illustration. Then Ex equal to P1x1, P2x2, P3x3, P4x4. Then the value means equal to 190. Since a man is expected to get only 190, which is less than the entrance fee of 200, he will not play the game. Then illustration 25. Two cards are drawn at random from a pack of 52 cards. What is the probability that it will be two aces, a diamond and a heart, a diamond and a heart, a king and jack, and fourth one a heart and an ace. Total number of cards in a pack 52. The total number we're drawing two cards means 52C2. That is 52 fact, I mean 1326. How it's 52C2 is calculated is as explained in previous illustrations. The number of ways of drawing two aces means 4 into 4C2, thereby 4C3 by 1 into 2 equal to 6. Hence the probability of getting two aces is 462 by 52C2. You understand? First one 52C2, that would be taken in the denominator, thereby 6 by 1326, that is 0.005. The number of ways a diamond and heart card is drawn, and means you have to multiply, that is 13C1 into 13C1, 13 into 13 equal to 169. The probability of getting a diamond and a heart is, the number of ways you have derived is 169 by 1326, because the total number 52C2 is 1326. That was applied here. And third one, the number of ways a king and jack are drawn, equal to king 4C2 C1 and 4C1. 4 into 4 equal to 60. Probability of getting a king and jack is 16 by 1326. Very clear. Answer is 0.12. Number of ways a heart and an ace are drawn is 13C1 into, and means multiplication, 4C1 equal to 13 into 4 equal to 52. Thereby 52 by probability means it would be less than 1. It would not be 52. Thereby 52 by 1326. That is denominator total. That is 52C2 value. That is 0.039. Then 10C7 equal to 10 factorial by 3 into 7 factorial. The value seems to be, that is 10C3 equal to 10C 10 minus 3. Okay. Thank you.